Hi, welcome back to Math 107. So in this chapter, I'm going to talk about triangles. So here are the difference of triangles. We have a acute triangle. So what's acute triangle? An acute triangle means a triangle with three acute angles, which is this one. These angles, they all are acute angle, which means the measurement is between 0 to 90 degrees. So obtuse triangle means a triangle with one obtuse angles, which is obtuse angle means the angle that greater than 19 degree. Just need to have one, then we can call this obtuse angles. So right triangle means a triangle obtaining one right triangle. So these we call it, right triangle. Just need to have one. Okay, so the sum of the measure of these three interior angles of a triangle is always 180 degrees. So that means in this acute angle, these three angles, the sum of these three angles, angle A, B, C, is going to equal to 180 degrees. Similarly here, if you have a triangle XYZ, the sum of these interior angles is equal to 180 degrees, similar to the right triangles. So look, a triangle have two angles that measures 13.5 and 17.5 degree. Find the measure of the third angles. So we know that, hey, the sum of the measures of three interior angles of a triangle is always 118 degree. So that means we can set the equation as 13.5 degree plus 17.5 degree plus x, the unknown angles, equals to 118 degree, and then solve algebra. So we get x equals to 17 degree. Okay. So now this is some special angles. So first of all, we need to know what is congruent means. So incongruence means side of a equal length. We call it a congruent side. So equilateral triangle. An equilateral triangle means these sides, a triangle whose three sides have the same lengths. These sides of equal lengths are called congruent sides. So that means the lengths of these three sides are equal to each other. So equilateral triangle has nothing to do with their angles. But actually for equilateral triangle, every interior angle is going to be equal as well, 60 degrees. So isosceles triangles. Isosceles triangle means a triangle with exactly two congruent sides. Not three, just need to have two. Such as this one. These two equal, so we call it isosceles triangle. And then the other one is called scalene triangle. A triangle which with three sides are different lengths. Such as this one. They can be obscure, they can be acute, they can be right triangle. Okay. So how do we describe a triangle? To describe triangle more specifically, we can use the information that we know about the size and then the angles. Such as if I give you this graph. So how many information that you have from this graph? We know that, hey, this is a right triangle, right? Because you have a right angle. And then you have two congruent sides in here. This is foundation means congruent. So that means we can call it is a what? isosceles right triangle. Okay, so now the next one is I want to talk about how to identify congruence and similar triangle. So two triangles, they're congruent if they are exactly the same size and shape. In congruence triangle, the measure of the corresponding angles and the lenses of corresponding side are equal. Okay, so for example, you have two angles like that. Everything are exactly the same size and same shape. Sometimes they can be in different location. Let me give a better example, such as this one. A, B, C, E, F, D, E, F. Okay, look at these two triangles. They all have a 19-degree, and then one angle is 13-degree. The other one is 60-degree. Is this congruent? We don't know yet, because when it comes to congruent, they have to be the same size and same shape. So that means the corresponding angles, the measure of the corresponding angles is equal. Also, the lenses of corresponding side has to be equal. So now I claim AB equals to DE and BC equals to EF, and then AC equals to DF. Then I can say, hey, these two angles, they are congruent. I can say angle ABC and angles DEF are congruent. Because every pair of the corresponding side have the same correspondent has the equal lenses, and every pair of corresponding angle have the same measures. Look, the position, they don't have to look like the same. They can be rotated 90 degrees or on the other plane, that's fine. As long as the corresponding side and corresponding angles are the same, then we claim this is a congruence. Okay, so what is similar? So now take a look. So now I have two triangles here. Okay, so now these two triangles, clearly they're not the same size, right? You can say these two is congruent because there's no way you will find the corresponding sign that they have the equal lenses. However, they do look like they do resemble one another, right? So because they have the same shape, they look close to each other. So now here's the definition of a similar triangle. If they will have the congruent angles, we will call this is a similar triangle. That means if these angles, angle T equals to angle C, angle X equals to angle B, and then R equals to angle A, then I can say, hey, this is a similar triangle. So you can use, for some textbook, you will see a hash mark on a similar the congruent angles. They will mark it as a hash mark, such as this one, they will have one mark, means, hey, this two is going to be equal, and this was two hash mark. And then you will have three hash mark. that shows that, hey, these three angles, they equals to each other, one to another. Sometimes you will see some textbook is going to look like this way. Not the hash mark, but with the original way that I draw it. So this angle equals to each other, and then angle R equals to angle A. I do a hash mark, and then angle X equals to angle B. So that shows that, hey, this is corresponding to each other. So that's another way to define a similar triangle. So the similar triangle, if the ratio of the pair of corresponding sides are equal, the triangle is similar. So what's that mean? That means I give you two triangle, A, B, C, and then another triangle, E, D, F. These two, I say that, hey, these two is obvious they're not congruent because the lenses are not equal. And now we don't know if the angles, the measurement of the angles are equal because they didn't give you any information. However, they give you the lenses of the size of each side for each triangle. So now, if the ratio are the same, we can say, hey, these two are similar. So now take a look. Side AB over the ratio side ED equals to 3/9, which is 1/3. And then side BC over side EF is equal to 4/12, which is, when you simplify, is equal to 1/3. And then the last side is side AC over side DF is equal to 6/18. When you simplify, it's also equal to 1/3. Look, their ratio of the pair of the corresponding side are equal. So that means what? By the definition, these triangles are also similar. Okay, so here's an example. We can use that to find the mixing lenses of the measurement. Finding the missing measurement in a triangle if you know some of the measurements in a similar triangle. So here we have two triangles, which is C. So this is given. So by the given information, we know that, hey, the corresponding angles, they're equal to each other because you can see this hash mark. And now they want you to find N, the lenses of BC. So by the definition of similar triangle, first of all, you need to state that, hey, triangle A, B, C, and triangle X, Y, Z are similar. You need to state that. We know that they're similar. So that means what? The ratio of the corresponding side are proportional. That means the proportional should be the same. So that means the ratio of CB over ZY should equal to the ratio of BA over YX, which is these two is equal to these two. So now we plug in the number. We have a BA equals to 6 yx equals to 1.5, and CB we don't know, is n, and then zy equals to 2. Now we can solve for n. You can multiply 2 on both sides to get rid of the 2. So I have n equals to 12 over 1.5. So n is equals to 8. That's how you find the measurement, by using the similar angles. Okay. That's it for the triangle. Next time we'll talk about Pythagorean theorems.